what we want to do is just rewrite our common denominator all over again. Just keep bringing it down line by line. And the numerator we can do some distribution with. 6a squared plus 2a squared minus 2ab. Well, you can see as I can that we have like terms that can be combined, and so the numerator will become 8a squared minus 2ab over this common denominator, which I will keep rewriting. I also see that I can factor a 2a out of the numerator. Now, let's do that. 2a times 4a minus b over a times a plus b times a minus b, and I can at least cancel those a's with each other and reduce my answer a little bit. So my final solution, or way of writing this, will be 2 times 4a minus b over a plus b times a minus b. On number 14, let's factor these two denominators into x plus 3 times x minus 2 and x plus 3 times x plus 2. And then find that our common denominator will have x plus 3 and x minus 2 in it in order to make the first fraction happy, so to speak. And the second one says, yes, x plus 3 is fine, but I need to have an x plus 2 in that denominator. Now we need to convert these to the equivalent fractions. This first fraction, the new thing in it is the x plus 2 down below, so the 3x down up in the top left is going to get multiplied by x plus 2 to make it part of the equivalent fraction. The second fraction had an x up above. We see that it has been multiplied by x minus 2 over x minus 2 to get to this new equivalent form. Our next step will be that of distribution. We will have 3x squared plus 6x plus x squared minus 2x over these three parentheses. And after that, we will then begin the combining like terms phase. And that will give us 4x squared plus 4x over these three denominators, and I'm getting a little bit lazy there, and I can see that I can factor out a 4x. That will give me 4x times x plus 1 over these three parentheses, x plus 3, x minus 2, and x plus 2. And it turns out that nothing is going to cancel this time, which is the case every once in a while, but we've at least verified that this will not reduce any further. Let's factor our denominators on this next problem. The first one factors into 3n plus 1 times n minus 3. The second one, I wish that was reversed. I am going to factor out a 2 and have 3 minus n, but I really wish that was 2 times n minus 3 instead. So I've done a little bit of a switcheroony. By making that change, I need to change this plus sign to a minus sign. We've used the negative 1 technique, noticing that 3 minus n and n minus 3 are equivalent but off by a sign. Now the third denominator cannot factor, it's just going to stay 3n plus 1. Now we are going to write our common denominator. The first fraction dictates that 3n plus 1 times n minus 3 be a part of it. The second fraction says, oops, I need to have a 2 out in front, so I put that off on the far left there. And the 3n plus 1 we already have for the third fraction, so that will be what we need. Now we see how have these fractions changed. This first fraction has only been multiplied by 2, so I've got 2n up above times 2 making 4n. Minus, okay, we have the 2, we have the n minus 3. The new part is the 3n plus 1. Notice I'm being very careful using parentheses because this binomial follows the subtraction sign, and I'm going to need to distribute that negative on the next step. Minus 2 times, well, this next expression down below needs to get multiplied by both 2 and n minus 3. So I'll put another 2n and an n minus 3. Okay, now we can continue on here. There will be no change down below. 2 times 3n plus 1 times n minus 3. And up above, I'm going to do my distribution. 4n minus 3n minus 1. And then I'm going to treat this 2 times 2 as a 4 when I do my distribution. So negative 4 times n is minus 4n, and negative 4 times negative 3 is plus 12. And I see right off the bat that I have a 4n minus 4n that can subtract easily. And so I will have negative 3n plus 11 all over 2 times 3n plus 1 times n minus 3 as the final simplified version here.